This is 8EEB6. This standard has 3 parts to it. We're still dealing with equations and expressions. The first part is we're going to use similar triangles to explain that the slope is the same between any 2 points on a line on a coordinate plane. As you can see down here, we've got a line. It goes to all these points, F, D, A, C, and it even goes to the origin. Remember, the origin is the point 0, 0. And what we're going to do is we're going to use these different triangles to prove that the slope is the same no matter where we check it on this line. Okay, let's remember a few things about slope first. Slope. We use the letter M for slope. Now, there's lots of ways to look at slope. Slope can be thought of as rise over run, which tells you how much a line goes up or goes down, how steep it is, how much it rises over the same amount that it runs, okay? Or another way to look at that is the change in y over the change in x. We know the y-axis is up and down. So rise would be the change in y, how much we go up versus how much we go over. Okay, so we're going to look at finding the slope at different places on this line. Let's start by finding the slope using line segment AC, that part of it, the slope of line segment AC. If I'm going from A to C, well, they started going from C to A. In this case, on this triangle, they went down 2, and in the negative direction, see, from 2 to 1, they went back 1. My slope, my rise over my run, then would be -2 divided by -1. -2 over -1. If I divide -2 by -1, I'm going to get a positive. A negative divided by negative gives me a positive. This is 2. What this 2 actually tells me is that it's my rise over my run. Think of it this way. 2 is equal to the rise over run. Now, I can divide this 2 by 1 and not change it. This means I go from wherever I start, I rise 2 and I run 1 before I give another point. Look at it, guys. I can see it here. If I rise 2 here and run 1, I'm going to get from A to C. It's like a translation. Up 2 over 1. Okay? Now, the whole purpose in this is to prove that I would get the same slope on this line here, this long line here, if I check it right here from D to F. Let's find the slope if I check it on line segment DF. Notice they've drawn our right triangle on DF. This is our rise, this is our run. We're going up 1, 2, 3, 4. I'm rising 4, going up 4. I'm running 1, 2, 2 in the positive direction. So when I talk about rise over run here, it's 4 over 2. 4 divided by 2 is 2. I have the slope of 2 on both places. Now remember, we talked about slope being basically how we get from place to place. From between each point on an axis, or I'm sorry, between each point on grid lines, I would go up 2 and over 1. Let's look and see if this works here. If I start here at this point, I go up 2 and over 1, I'm right there. Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. The slope is the same no matter where I check it on this line. Now, the second part of this standard, derive the equation y is equal to mx for a line that goes through the origin. Again, we talked about the origin. The origin is the point 0, 0. Let's start out by talking about a line. Y is equal to mx plus b is our slope-intercept form of a line. B is our starting point. It's called our y-intercept. The y-intercept is where we cross the y-axis. Here's our y-axis, goes up and down. See, it says y up here. There's our y-axis. This is crossing, this line is crossing it right here. It's intercepting it right here. It's 0, 0. Now, wherever it crosses the y-axis is called the 0B. This is the point where it crosses. Notice on the y-axis, the B is 0. That's where it's crossing. So if we start with y is equal to mx plus b, and we cross at B, B is our y-intercept, it's where it crosses the y-axis, then y is equal to mx plus 0. Plus 0 doesn't really add anything or take away anything. This equation could simply be y is equal to mx. Therefore, when it says derive the equation y is equal to mx for a line that goes through the origin, they're simply saying b is 0, so you can leave it out. So let's write the equation for this one. Y is equal to mx. We've talked about m before. M is our slope. We can find it with rise over run. Same thing as change in y over change in x. Let's find 2 points where it crosses. We have it on a grid line. See how that's right there on a grid line, that point is? And so is this one. Okay, let's draw a right triangle between the 2 points. See, I've drawn a right triangle between the 2 points. To get from this point to this point, rise over run. Remember, m is rise over run. I go down 1, 2, 3. Down 3. So my change in y is -3. You can do it this way too, guys. You could subtract those and get there. And I go over 1, 2, 3, 4, 5. Down 3 and over 5. This equation becomes, let's substitute this in for the m, y is equal to -3/5 x. Now, just so we can understand, I could also have taken these 2 points. I have 2 points that are here. You notice how this point is at 0, 0? You notice how this point right here is at 5, -3? We've talked about slope being change in y over change in x. Let's find the difference in my y's here. That would be 0 minus -3. And this would be 0 minus 5. 0 minus -3 is 0 plus 3, which is 3. 0 minus 5 is -5. That would give me, same thing as the -3/5. I can get the slope either way by putting 2 points into a chart and finding the difference in y over difference in x, or by using rise over run. Let's try another one of these. A says building birdhouses to sell online. Write an equation to model the relationship between the number of birdhouses built and the number of days she has been building them. Okay, let's start with our linear equation. Y is equal to mx plus b. Our b is where our line crosses the y-axis. Here's the y-axis. Here's where it crosses. It crosses at the origin 0, 0. Okay, so our b is 0, which tells me that I have 0 birdhouses built in 0 days, right? When I start out, I don't have any birdhouses built. So y is equal to mx plus 0. This plus 0 doesn't change anything, so we're going to stick with y is equal to mx. We need the slope. We know that slope is rise over run, which can be known as also change in y over change in x. If I look at this, you got to check your grid lines carefully. Do you notice that my scale is 1, 2, 3, 4? Here it's 1, 2, 3, 4. So all I need to do is build me a right triangle and use rise over run if I want to. Let's find a place where they both cross the grid lines. There it is. I'm going up 3 and over 1, 2, 3, 4. Over 4. Up 3, over 4. My slope, my rate of change is 3 over 4. Let's put that in for m. We're going to substitute for m, 3 over 4. Y is equal to 3 over 4x. What does this 3 over 4 actually mean? Since 3 is your change in y is the number of birdhouses built. That's on your y-axis. 3 birdhouses built, and the 4 is days, the x-axis days. 3 birdhouses built in 4 days. Now, let's look at the third part to this particular standard. Derive the equation y is equal to mx plus b. See, we've been starting with this for a line that intersects the y-axis. Now we're not intersecting at 0, 0. We're intersecting somewhere else. Let's write the equation. Y is equal to mx plus b. Our b is where it crosses the y-axis, and that's right here at 1. And since it's that 1, we put 1 in place of b. Oops. We're going to substitute 1 in place of b. It's where it crosses the y-axis, where this line crosses it, where it intersects it. Now, what else do we need for this equation? We need the m. The x and the y's are just the values on the line. We need the m, the slope. We've talked about m. M is our rise over run, or we can also talk about it being our change in y over change in x, because y is our axis that goes up and down, x is the one that goes left and right. Okay, here's one point, here's another. Let's draw our triangle, our right triangle. See, that's a right triangle. It's right on the grid lines. Now, here's the y-axis. Our change in y, or our rise, would be going up 2. We're going up 2. And then I'm going over 1, 2, 3, 4. So my m is change in y up 2 over 4. Can I reduce that? If I reduce that, wouldn't that be 1 over 2? I take 2 off of each one of them. Okay, so I'm going to put a line here so we'll know we're working different things. My m is equal to 1/2. I'm going to plug it in here. Y is equal to 1 over 2x plus 1. 1 over 2 means each time I go up 1, rise 1, I go over 2. Let's see if that would give me points on here. Up 1, over 2. Yep, there's a point. Up 1, over 2. Up 1, over 2. Yep. And I know it's a positive slope because this is going up as I go from left to right. Now let's try one with a negative slope. The coordinate grid below shows the distance the delivery truck is from a warehouse. Distance driven, time spent driving. This is the distance from the warehouse. After driving, different number of hours. Okay, sometimes I try to look at it and read it and figure out kind of what it's telling me. So this says at 0 hours, it's at 600 miles from the warehouse, right? At 1 hour, we are, let's see, 4, 5, 6. 1 hour, we're over 500 miles from the warehouse. At 2 hours, we're less than 500 miles from that warehouse. Okay, so that's kind of what it's telling me. Write an equation that corresponds to the line in the graph. Explain your equation. Okay, well, we're going to start with y is equal to mx plus b. That's the equation for, that's the form for a linear equation, slope-intercept form. Now, we've talked about this. The b is the y-intercept. The b is your y-intercept. In fact, the coordinates for your b point will be 0, b. It's where your x value is 0, your y is b. We're going, but I'm not looking at a big coordinate grid here. Well, think about it. you could actually extend this out, and you would have quadrant 1, 2, 3, 4 if you did this. Because everything's positive here, they've left this part out. Where's our B? It's where this crosses this y-axis here. Where does it cross the y-axis? At 600. That's where we start. He starts 600 miles away from the warehouse. B is 600. That's point is at 0, 600. Okay? 0, 600. That's your point right there. Now we need our M, our slope. Now notice, although our grid lines here are scales 1, 2, 3, 4, here our grids are in what? If this is 200, wouldn't this be 100? So each of these lines represents 100. Let's find 2 points that we can use. Okay, here's one where it crosses the grid. And there's one where it crosses the grid. We can draw our right triangle. We know M is equal to rise over run, or M is equal to the change in Y over the change in X. Let's look at this change in Y. On our Y-axis, we are going down 100, 200, 300. We're going down 300, and we're going over 1, 2, 3, 4, 5, and over positive 5. Our change in Y is negative 300. Our change in X is 5. We could have found this way too, guys. We could have taken our points. Our change in Y would have been 600 minus, let's see, what is this at? 300 over 5 minus 0. That also would have given us 300. 0 minus 5. Sorry. 300 over negative 5. This would give me negative 60, and you get the same thing here, negative 60. In the place of M, we put negative 60. Y is equal to negative 60x. This tells me, plus 600, this tells me I'm starting at 600 miles away from the warehouse, and I am getting 60 miles closer. I'm taking 60 miles off my distance from the warehouse each hour. Okay? Now I want to go back to one other. Write an equation for a line from the coordinates of points. What if they just give you the points? You don't have any graph paper. How could I do this? Well, y is equal to mx plus b. We talked about the b being where it crosses the y-axis, right? If I started out plotting this, you see how this is 0, 1? Wouldn't that be right there at the point 0, 1? So this point is going to go through this right here. It goes through the y-axis at 0, 1. This is, anytime you've got 0, whatever the other point is your b. So we're starting at 1. Y is equal to mx plus 1. Now we need to find m. What if we set us up a chart with x's and y's in it? We know that m is equal to change in y over change in x. This is the x and that's the y for this point. 0, 1. X and y. 1, negative 3. I don't even need the third point. My change in y would be 1 minus negative 3 over 0 minus 1. 1 minus negative 3 is the same thing as 1 plus 3. 0 minus 1 would give us our negative 1. That gives me 4 over negative 1, which is negative 4. Y is equal to negative 4x plus 1.